This was the introduction about the our Verilog HDL, and completely we studied that. And also we have seen the what are the lexical conventions, and also some data types, and also we have seen the what is the model. Related to that model, we have the ports also. Okay, how the ports are to declared, and also we have the naming of the ports, and also ordering of the ports also. Okay, in this last classes, these many classes we studied the first model and second model. Today we'll start with the new model, that's the third model, with the writing a program in the gate level modeling. Okay, gate level model or structural model. Gate level modeling, structural model. Gate level modeling. Okay, what is the gate level modeling? Usually the our digital circuits will have the gates. Okay, and also we implemented the each and every my circuit has to be implemented with the what the different logic gates. Okay, these logic gates, while referring the names of that logic gates, will write the program. Okay, while whatever we'll look at the digital system, that based on that one only we'll write the, without knowing the concepts, whatever we have the logic gates, and the logic gates, what type of logic gates we are using, what the operation related to that particular logic gates, based on that only we'll write the program in the Verilog HDL. So that here the how many gate types are there, so that we need the gates. Okay, gate types. How many gates are there? There are 3 types are there. One is what the basic logic gates. Another one is what the universal logic gates. Second one is the derived logic gates. Derived logic gates. Okay, basic logic gates. Okay, if you should know the what are the basic logic gates. First one is what the NOT gate. Another one is the AND gate. Third one is the OR gate. These are the basic logic gates. Based upon only these 3 logic gates, we'll derive the few more logic gates like XOR gate, XNOR gate. Like this, we'll have the different types of logic gates also. Even we can also develop the universal logic gates. Why we call the universal logic gates? These NAND gate and the NOR gate. Okay, usually my ICs are usually implemented with the NAND gates or NOR gates. You should remember, because the only one type of logic gates if I use in while implementation of the any ICs. Thereafter we'll get what the reduce the what the cost effective, also will get the good cost effective also, and also designing of the that particular logic that particular digital system in the IC will be or the remains very simple one. Okay, that's what we call them as the universal logic gates. Why we call them universal gates means these types of NAND gates or NOR gates we can use the alone. Okay, single one only for the implementation of the any digital systems, any circuit. That's what we call them as the universal gates. Okay, basic logic gates, derived logic gates, and also universal logic gates are there. For sometimes we will concentrate on only what the AND and OR gates only. Just other mal concentrate ಮಾಡ್ತೀವಿ AND OR gates. Okay, what are the AND and OR gates? These are the AND and OR gates are what we get the scalar output, that we call the scalar output. Whatever we have the inputs for the AND gates, these to be called the variables. Okay, these to be called say for the variables. The variable can have the different values, so that the only one output will have. Okay, will not change the output. This is what the scalar output we call the scalar output. Whatever we giving the inputs, those to be what the variables that can have change the value also. Okay, and the list of okay, we have the some terminals also for the, as the terminals means what these we calls what the inputs. Okay, this we calls the output. We have the multiple number of inputs for the all the logic gates, and even the we will have the only one output. For every gate we will have the only one output. The inputs are nothing but the we have the we inputs. Okay, for the variables will give the some operation to this one. This one will do the some operations logic circuit that will give the output in the form result in the form of output. Okay, this we call as the inputs, then this we call this one we call as the output. Okay, whatever we have the logic gates, we still have this AND gate, OR gate. OR gate is also having the two inputs and also only one output. NOT gate is having how many inputs? NOT gate. NOT gate is having the how many inputs? 2 or 3? 3 na? Only one, na? Okay, only one. This is what we call as what the inverter. So that whatever you have the input, that one will be inverted form. That's the A bar. If I have the input as the A, definitely the output would be what here the A bar. That's the inversion. We have the it will perform the AND operation as nothing but the that will perform the what the multiplication operation as the y equals to A dot B, and also this is what the OR gate. This one will perform what the OR gate will perform what the A plus B. But means what the yaro ಒಂದು ಎರಡು ಅದ ಅಂತ ಇಟ್ಕೋ. A ಮತ್ತು B ಅದಾವ. A ಮತ್ತು B. A ಮತ್ತು B ಒಂದು ಬಾಯ್ ಅದ ಒಂದು ಗರ್ಲ್ ಅಂತ ಇಟ್ಕೋ. They will be having the some affection over there. They will do what they can do the romance, they can do the kiss, whatever they if you are their lover. But we call them as the operators. We call them as the operands. We call them as the operand. We call them as the operand. This one we call is what the operator. This operator is not the. This is what for the OR gate purpose. If you go on, this one is what the derived logic gates will have the different operator, and XOR operator will have the some more operation, some other operator. NAND gate will also do what the some operations. That will be called the some operator with the help of what the NAND operations will perform the exactly the inversion of the AND gate, and also NOR will perform what the inversion of the OR gate. Whatever we have this we call the operands, this we call the inputs, we call the operands. Whatever the operation will perform this logic gates we call the operator. Okay, this will do the some operations, operand, and this is the output, and this we call the operator. Okay, what the operator we have for the AND operations? Only the dot operator. It will perform the what the multiplication. It means for the if two inputs are high, then only my output is what the high. Otherwise it is 0. If any one input is low, definitely the output is also a low only. That means for the 0 0 0 0 1 1 0 1 1. If I have the A as the B, okay, A dot B is what the if the both inputs are high, then only the my output of the AND gate is high. It means here the we have both inputs of A and B have the output as the 1 1 input only 1 1. That's what the output is what the 1 only. That the remaining input for the remaining input combination, the output is what the 0 only. Because of the my condition for the AND operation is what the both inputs should be high, then only the output of that particular AND gate is what the high, otherwise it is 0. Similarly for the OR operations also 0 0 0 1 1 0 1 1. Why I am taking the 4 combinations? If the 2 to the power of n number of combination I should take, how many inputs are there here? 2 are there, A and B. 2 to the power of 2 is how much? 4. So that I can have the 4 bit of 4 input combinations as the 0 0 0 1 1 0 1 1. So that I can say it's A as the input, another B as the another input. So that Y is the what the Y equals to A plus B for the OR operations. What we are doing? We are using the operator as the plus operator will do what the only whenever the any one input is high, then the output is high, otherwise it is a 0. Any one input is what the one input is there 0 1, output is 1. Output is one input, both 1 and 0, that is the output is 1. Both input are high, then also its output is high, otherwise it is what the 0. This is we call as the truth table for what the for the OR gate, truth table for the OR gate. Similarly for the NOT gate is also having the input as the A and the output as the Y. Okay, 2 to the power of n. 2 to the power of n is how many inputs are there? Only one input is there. That's what the 2 to the power of 1 is, the two inputs. Okay, two inputs combination as the 0 or 1. For the one variable can have the two inputs, either it is what the 0 or 1. The output for the NAT gate, whatever the I have the input, that is the inverted form. The inverted form. 0 idra 1 agutta, 1 idra 0 agutta. 1 idra 0 agutta, 0 idra 1 agutta. This is what we call as the inverter. Okay, this is what we call as the inverter. These are the some basic logic gates, and also it's related truth tables also here. And also we have the so many different types of logic gates here, and also we have the different types of truth tables related to this one. Just to copy the things whatever I said now. Okay, gate types, just to take the heading as the gate types. Gate level modeling, in this you can take the subheading as the gate types. A logic circuit can be designed using a logic circuit can be designed using logic gates. ಗುಂಡಿ ಹಾಕೋದು ಮೊದಲ ಬಟನ್ ಹಾಕೋದು. Okay, a logic circuit can be designed using logic gates. Next point, Verilog supports basic gates. Verilog supports basic logic gates derived. Next, basic Verilog supports basic logic gates as ಬರ್ಕೋರು ಹಂಗೆ ಇದ್ರ ಮುಂದೆ ಸೇಮ್ ಇದಿಷ್ಟು ಕಾಪಿ ಮಾಡ್ತೀನಿ ಬರ್ರಿ. ಬೇಸಿಕ್ ಓಕೆ, ವೇರ್ಲಾಗ್ ಸಪೋರ್ಟ್ಸ್ ಬೇಸಿಕ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್ ಅಂತ ಬರ್ದು ಇದರಲ್ಲಿ 3 ಟೈಪ್ಸ್: ನಾಟ್ ಗೇಟ್, AND ಗೇಟ್, ಆರ್ ಗೇಟ್. ಡಿರೈವ್ಡ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್ ಅಲ್ಲಿ XOR, XNOR, ಅಂಡ್ ಆಲ್ಸೋ ಯೂನಿವರ್ಸಲ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್ ಅಲ್ಲಿ NAND and NOR. ಜಸ್ಟ್ ಟು ಕಾಪಿ ದಿಸ್ ಒನ್. There are two classes of basic gates. Next, there are two classes of basic gates. Yes, come in. There are two types of basic gates. There are two classes of basic gates, namely classes of basic gates, namely in this basic class gates only we can give the gate names. Okay, one is what the AND OR gate. Next, second one is what the buffer or NOT gate. NOT gates. Okay, there are two classes of basic gates, namely first one is what the AND OR gates. Second one is what the buff is nothing but the buffer type of gates. Another one is what the NOT gates. Okay, just to copy the as A, B, Y, A, B, Y. This is what the NOT gate. Sorry, this is what the only triangle form. Okay, triangle without the bubble, we can say it's for the buffer. Whatever the input is there, that one is what the output. ಇದು ವೈರ್ ಇದ್ದಲ್ಲಿ ಏನಿರುತ್ತೆ, ವೈರ್ನಾಗ ಏನಿರ್ತದ ಇನ್ಪುಟ್ ಅದೇ ಔಟ್ಪುಟ್ನಾಗ ಬರ್ತೈತೆ, ಅದೇ ವೈರ್ನಾಗ ಬರ್ತದೆ. ಸಮ್ಟೈಮ್ಸ್ ಇನ್ ದ ನೆಸೆಸರಿ ಟು ಡಿಫೈನ್ ಮೈ ವೈರ್ ಆಸ್ ದಿ ಬಫರ್. ಈಗ ಯಾವ್ದಾದ್ರು ವೈರ್ ಬಂತಂತ ಇಟ್ಕೋರಿ, ಕನೆಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಗೇಟ್ಸ್ ವಿ ಕಾಲ್ ದಮ್ ಆಸ್ ದಿ ವೈರ್. ನೀವು ವೈರ್ ಎಂಬುದು ನಾನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ಬೇಕಾಗಿರ್ತದ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ವಾಟ್ ದ ಗೇಟ್ಸ್ ಅಲ್ಲಿ ಫಾರ್ಮ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅವಾಗ ಓನ್ಲಿ ದ ಟ್ರಯಾಂಗಲ್ ಫಾರ್ಮ್ ದಟ್ ವಿ ಕಾಲ್ ಇಸ್ ವಾಟ್ ದ ಬಫರ್. We don't have the any input variation, output variation. Whatever the input is there, that one only output. We call them as those called as what the buffer type of gates. Okay, buffer type of gates. And also if you have the one buffer gate, that's the triangle with the bubble form, that one we call is what the not gate antivi. Yake not gate anta irtivi, this is what the inverter, sometimes called as the inverter also. A is what a inverted form, A bar. The whatever the input is there, output will get the inverted form. That is, if you have the 0, definitely the output is what the 1. If you have the input as the 1, definitely the output is what the 0. We call them as the not gate. We just to write the AND gate. This is what the OR gate. This is what the buffer, and also this is what the NOT gate. You should copy these things. Okay, all the basic gates. Okay, barkore. In the list of gates, drama barkor drop, just copy that one. Okay, based on these basic logic gates, and we will write the program in the with the help of for the gate level modeling or structural modeling. ಯಾವುದು ಗೇಟ್ ಇರ್ತದೋ you should have to able to identify that particular gate name. ಇದು AND gate ಅಂತ ಕಣ್ಣಿಗೆ ಕಾಣ್ತದ, AND gate ಅಂತ ಅನ್ನಕ್ಕೆ ಬರಬೇಕು, ಅಂದಾಗೆ ನೀವು ಪ್ರೋಗ್ರಾಮ್ ಬರೀಲಕ್ಕೆ ಬರ್ತದೆ. ಇದು ಆರ್ ಗೇಟ್ ಅಂತ ಕಣ್ಣಿಗೆ ಕಾಣ್ತಿರ್ತದೆ, ಆರ್ ಗೇಟ್ ಅಂತ ನೋಡಿದ ತಕ್ಷಣ ಗೊತ್ತಾಗಬೇಕು. ದಟ್ಸ್ ವಾಟ್ ವಿ ಶುಡ್ ಹ್ಯಾವ್ ದ ಬೇಸಿಕ್ ಐಡಿಯಾ ಅಬೌಟ್ ದ ಆಲ್ ದೀಸ್ ಬೇಸಿಕ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್. Sometimes many of the students after the completion of their 7th sem or 8th sem, they are unable to tell the answer as the what are the how many inputs for the NOT gate. They will usually tell the 2, 3 like this because only the NOT gate is what the inverter, which is having the only the one input. Output is what the only one, that we call as the inverted form. Okay, in the list of gates, in the list of gate terminals, can have the in the list of gate terminals can have the many inputs but only one output. Usually the gates usually will have the gates this AND gate, OR gate, and the other type of XOR gate will have the inputs more than one also, but the only one gate, that is the buffer, and also we have the another one gate is there, NOT gate, will have the only one input, only one, but all the logic gates will have the only one output, that we call the only one output terminal. That's what we are telling, that each and every logic gate will have the many inputs, but the only one output, The next is what the okay, truth table for the all the basic logic gates. We'll see that one. Okay, we should have the know the what the operation it is performing. My logic gate will have that one some operations. Okay, that will do the particular operation only. Okay, and the OR model, OR gate is the AND operations model. The each and every logic gate will have their own operations as the truth table, that is to be given in the form of truth table. Truth table is what the one of the table which is having the input and also output in the form of what the column and the rows, column and rows form. Okay, just to copy this one as the truth tables for the each and every logic gates as the AND gate. First one is what the AND gate, just to take the heading as the AND gate, and also 0 as the inputs 0 0, 0 1 1 0 1 1. This is what the inputs A comma B. That's what the A and B are there. Okay, and also I will perform the operations. Okay, some perform the operations as the AND operations. AND operations will be have the output, that is what the y equals to A dot B. Then the I told you that there is a AND operations will perform. The output is what the only one, only when the both the inputs are high, then only output is high. Otherwise it is what the 0. Otherwise it is what the 0. Then the will give the 0 0 0 only. That's to copy this one AND operations. Similarly, for the OR operation, we'll have the gate names as the R A dot A comma B. Then the outputs are inputs combination 0 0 0 1 1 0 1 1. The OR operation is what the y equals to A plus B. We have the operator as the plus operator. It will do the binary addition. Okay, binary addition, that is the 0 plus 0 is how much? 0, and 0 plus 1 is what the 1. 1 plus 0 is what the 1. Binary operation 1 1 is what the 1. That's nothing but here what we are doing, only one the in our operation the condition is the any one input is high, then definitely the output is what the high. Otherwise it is what the 0 0 0 is there, 0 is there. Okay, just to take the below this one as the NAND A comma B, y equals to A dot B, sorry, A plus B. A dot B. That's what the whatever we have the NAND AND operation, that is the inverter form. Okay, for input combination 0 0 0 1 1 0 1 1. The output is what the whatever the we have the inverted. Okay, AND operations, that we call the NAND operations. For example, the my NAND gate is what the looks same as the AND gate only, but we have the only one bubble. Wherever we'll see the you see the bubble, just to mind this one as the not related to which what the inverted form of that particular gate. It's what the this is what the AND gate actually, but we are putting the bubble over there. Then definitely it will become what the NAND, so that it will perform the operations as related to AND only, but will give the get the output in the inverted of what the AND, inverted of AND. That one we calls the NAND. Okay, just to put the input as A comma B, y equals to y. Then the output would be what is the both so whatever we have the input combination for the AND, that is the output is what the only one, that is the only one the both inputs are high, that definitely the output is 1. That's the inverted form, that we call as the 1 1 is there, 0 remaining output for the 1 1. The output of the NAND is similar to the both for the NAT AND only, but the inverted of that AND operations we are getting. Actually, I already sent some PDF files. Okay, yesterday or today. Okay, that one I will carry whatever the DSDV materials is there. Just I will send today. But you have to give the seminar topics today. Okay, I will put that one in the Excel form. And also next is what the NOR. NOR is what the one of the logic gate. This is the derived logic gate. This is what the what type of gate this one? Derived or universal gate. This is one of the universal gate we have. So that input combination for the A comma B, the output is what the y equals to NOR only. That's the inverted of that one. So that there are two inputs for this NOR. The NOR is the one of the gate, that is the having the both inputs as the A and B and the only one output. Okay, this is what the OR gate. If I put the bubble in front of this gate, that will become what the NOR gate. So that I have the two inputs combination. That's what the 2 to the power of n means. What the 2 to the power of 2, 4 input combination I can have here. 0 0 0 1 1 0 1 1. Okay, as I told you that the OR operation is only high. The output of the OR gate is only high. If the any one input is high, definitely the output of my OR gate is high. This is what the OR gate. So that inverted form of this NOR is what the, if the is 0 is there, 1 1 0 0 0. That's the, just to copy that one only here. If the both inputs are high, if any input is high, definitely the output is not high, but the inverted form is what, low only. Okay, low. But it's both inputs are low, then definitely the output is what, the low in the OR gate, then the its inverted form is as the 1. This is what the NOR gate. Just truth table for the NOR gate is just to copy this one. Okay, next is what the I left. Next is what the XOR gate. XOR gate. Another one is what the XNOR. XNOR gate. Okay, XOR gate is what the one of the this is the derived logic gate. Okay, I can define this XOR gate as the, this is what the OR gate. This is what the OR gate. If X is coming, okay, if XR is there, thereafter I have the one that's the before the input I can have the one that the curve here, one curve is here. Okay, this is what the, hey, class ಮಾತಾಡ್ತೀರಿ ಬರ್ತಾರೆ ಕ್ಲಾಸಿಗೆ, ಬರೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಕ್ಲಾಸಿಗೆ, ಸುಮ್ಮನೆ ಕೂಡಂಗಿತ್ತ ಬರ್ರಿ, ಕೇಳಂಗಿತ್ತದ ಸುಮ್ಮನೆ ಮಾತಾಡಂಗಿತ್ತ ಬರಬೇಡ್ರಿ ಕ್ಲಾಸಿಗೆ. Okay, that's the OR gate. If you have the before the input I have the one curve is there, if the that will become what the XOR, that's what is called the OR with the one curve, we can say is for the XOR gate. Okay, similarly even I can also write the XNOR also, the same as the XNOR is the same as the XOR only, then the input combination for this one as the both two inputs combinations are there, then the output is what the only one, that we call the A only, Y only, that's the A comma B. As I told you that if you are getting the NOR, that is the NAND not inform, not there have to put the one bubble, that will become what the XNOR. This is what the XOR, that's what the XNOR. The truth table for this one, you can write the truth table for this one as the, I have the inputs as the A and B are there, two inputs are there, just to write the A and B. Y is the output, the output, the operator for this XOR is what the XOR, that's the plus with the circle, this we call as the XOR, okay. The similarly I can write the XOR is as the Y equals to A circle with the dot, this we call as what the XOR, this one is called as the XNOR, okay, this one is called as what the XNOR, okay. Truth table for this one as the input combinations both 0 0 0 1 1 0 1 1. A comma B, this the output is what the Y. Output that Y is what the operation as the A with the XOR, and this is what the Y equals to A bubble with the the circle with the one dot. We can say for the XOR operations. Whenever the both if any inputs, both inputs are high or low, then the output is what the 0, remaining are what the 1 1. This is what the XOR. This is what the XOR. XOR is the exactly opposite of the this one, so that I can have the 0 0 0 1 1 0 1 1 combination. So that output of this XOR is what the inverted of the XOR gate. That's what the, just to put the 1 1 remaining as the 0 0. Just to copy that one. Okay, another one I said you that buffer not. Still now we have seen the R and AND operations. R and AND operations. Next combination of basic logic gates is what the buffer or not. Buffer andrenu? Buffer andrenu? What is the meaning of buffer? Hey, buffer andrenu? What is the meaning of buffer? Huh? Buffer andrenu? What does it mean? Buffer andrenu? Buffer andrenu meaning gottilla? Buffer andrenu? Something extra. We should have the more than that one. Okay, whatever we have, that one is to be given. Second one is what the B combination, that's the buffer or NOT gate combinations. So that buffer and NOT gates, buffer or NOT gate will have the only one output, that we call the only one output, that is in the scalar form. This will not change the value output of this one. Scalar form. That is the output for scalar form. Buffer and output NOT gate will have the only one input. That's not in the scalar form. That's a vector form also. We consider only one input, only one input. For example, there are two basic buffer NOT gates primitives provided. One is what the buffer or not. First one is what the buffer. Buffer and full barela buf anta barittada. Amela NOT gate. Second one is what the NOT gate. Okay, this in this buffer will be shown with the only the triangle with the only input, only one input. Output is what the same as the input. Ili idaga ಏನು ಇರ್ತದ. Similarly, the NOT gate is having the buffer with the triangle, with the buffer with the triangle. That is the, if you have the input as the A, the inverted form as the A bar only. If I have the A, input as output as the A bar. If I have the input as the A bar, output as the inverted as the form of the input as A only. That's the here the there are, okay, even the how to represent my, if I know, okay, if I come to know this one is the buffer, before this one is the NOT gate, how can I implement with the model? Okay, there are three ways I can implement buffer. How many inputs are the buffers? I can give the instantiation as the buffer B1, so that I have to write the output faster. What is the output of the buffer over there? A only. The output I should have to write the output, then the input also they should have to write the input, whatever I have. Okay, then the for the NOT gate is also having the N1, the input as the output is for, should have to write the first, then the input I can write the input forms. Okay, whatever you have. Okay, even the I can write the buffer can have the more than one input also, more than one input also. If I have the collection of wires, if I have the collection of wires, then the buffer can have the more inputs, only one output, only one output, so that I can write the buffer with the N2 B2 with the inputs as the output is only one, that is the output. The inputs can be in 1, in 2, in 3, like this, in 4. But the thing is that the buffer can have the more inputs also sometimes, because the it's what the wire connections to the only one wire ಅಂತ ತಿಳ್ಕೊರಿ ಒಂದು circuit diagram ನಾಗ. Here this is the only one point that we can say for the 3 inputs for this buffer, and also I am taking this completely in the form of only one, that we call is what the Y, that's the output form as also. This one we call the buffer with the multiple inputs also. Okay, for example, two table for related to this one as the buffer in and output, so that I can write this one as the 0 0 is there. If the buffer input is 0, the output of the buffer is what the, if the buffer input is 0, output of buffer is what, 0 or 0 1 0 only. The output input is 1, definitely output is what, the 1 only. If I have the input as the x, that's the unknown condition, that's what the unknown. It's might be x can have the both values as the 0 or 1. X can have the values both, either it is what the 0 or 1. The output is what the same as the x only. If I have the input as the z, that's what the impedance. It means it's getting low, then the output will be what, the x only. Output is what, the x only. This is what the buffer to table. And also NOT gate is also having here, NOT gate. The NOT gate is also having the input and also output also. Okay, for the NOT gate I can have the 0 is there, then the output of that NOT gate is what is that, 1 or 0, 1. Then if I have the input as the 1, definitely the output is what, the 0. If I have the x, then definitely I can have the x only. If I have the z as impedance, then the x only. This is what the two table for the buffer inverter also. Just to copy that one. Delta. Okay, next one is what the consider the buffer if and buffer not. If is nothing but the either it has to select the one of that. Okay, if condition is only one, the it is to be true, then only it is select, other else it is don't select that one. That meaning of the if else condition. Okay, then the buffer in buff if and not if. not if. Okay, I am sending the buffer. Okay, I am sending the conditions toward the buffer logic and even the not logic also with the condition as the if. Either if it is a true, then only you'll select, other else you can don't select. It is to be implemented with the help of the buffer logic gates. As the some combinations are there. Buffer, bufif, buff if, not if, not if. Okay, not if. That's nothing but here here I have the buff if. Okay, if the buff if is what, the 1. Okay, if buff if is the 0, I can send the values here. Okay, if the buff if is the 1, only 1, then it has to select with buff if is the 0, not if 1, not if 0. How to design these type of logic gates with the help of the buffer gate? It's just to look at here. Okay, this is what the buffer. This is what the buffer is there. Whatever the input is there, that is what the output. We have the output also. Okay, there is the output also. But I am sending the condition is what, the bufif1. Okay, the condition control signal will be sent to what, the buffer gate through what, the control signal. This control signal we can say is what, the if statement. Okay, then if there is no, okay, there is no 0, there is no bubble over there, that's what the bufif is, right. If I put the buffer gate with the some control signal with the bubble over here, this one is called the bufif0. Bufif0. If I have the not if is there, not if 1. Okay, this is what the not gate. This is what the not gate. I am sending the control signal over there with the logic 1. If I am sending the control signal to the not gate as the 0, then I have to put the send the in the form of bubble over here. These are the logic gates related toward the bufif. Okay, this is what the in, this is what the out. You should have to mention in and out, in and out. They are sending the bufif1. This is what the bufif. This is what the bufif1. This is what the bufif0. This is what the not if 1. This is what the not if 0. Not if 0. These are the some conditions over there. While referring these only, we can write the truth tables for this one also, for all these 4 combinations. Bufif, bufif1. That's the control signals to be what, the 0, 1. Inputs combinations what, the 0, 1. Control signals to be what, the 0, 1, or else x, z. Control signals to be what here, the, and also input combinations would be what, the input combinations are the 0, 1, x, z. Okay, these are the some conditions are there. Okay, these are the control signals. These are the control signals. These are the input combinations we have. Don't come. Okay, this is what the bufif1. Okay, if the both are only 0, then the output combinations here the z. Just to copy this one, I will explain it. Just to copy this one. Okay, here I have the conditions as the bufif for the input combination as the 0, 1, X and Z, and also we have the similarly for control signals also I am sending here. Okay, control signals also I am sending here. While referring these two combinations, I have the output here. The for 0, 0 I have the Z combination, 0, 1, 0 is there, 0 X is there, L is there low, 0 Z is there, L is there. Okay, just to keep on this one. Okay, also 1 0 combination Z is there, 1 1 combination 1 is there, and also if the 1 with the X is there, H is there, 1 with the Z is there, X H is there. Like this I have to compare the rows with the column of the my input combinations and also control signal, then the this one will get the output form. Okay, this one is the output form. And also similarly I can write the buff if the 0 condition. Buff if the 0 conditions, just I am making the slight changes over here. Buff if the 0 conditions. Okay, this is what the buff if the 0 condition for the control signal inputs combination 0 1 XZ only. Control signals will be what the 0 1 XZ only. The combinations for this one is the only the second row, that's the second column will be changing here. Remaining would be what the same. That's the completely Z only. That's the if the buff is the 0, then the conditions would be for the second column will be what the Z only. Z is nothing but the if it is a 0 condition. Okay, the Z is nothing but the if the control signal is what the if the control signal is 0, then the definitely the output. Okay, if the Z only, if Z, okay, Z equals to, if Z is okay, if control signal is not a 0, it's nothing but the 1. Definitely the output would be what the either it is what the 0 or 1. If the control signal is what the if the control signal that's the if the control signal is what the if the control signal is what the 0, then the output would be what the Z only. If the control signal is 1, then output would be what the either it is what the 0 or 1. The control signal if you are sending the 0, definitely the output is what the 0 Z only. Z is nothing but the impedance. That is having the impedance value, it is what the impedance. If the control signal I am sending here the 1, it is having the output either it can be 0 or 1. Impedance is nothing but the inactive condition. Okay, if I am sending the control signal into the active condition, then here my digital circuit, okay, my logic circuit will work as the either it can give the result as the 0 or 1. If I am sending the control signal is 0, definitely my logic circuit will not work. It is what the impedance conditions means what the it is not at all giving the any working, it is not working over there. That we call as the Z. If the control signal is 1, then the logic circuit is in the active condition. It should give the either it is a 0 or 1. That is, it has to give the work. It has to give some operation. Either it can give the values as the output as the 0 or 1. This we call is what the control signals. Next is what the array of instances. If I have the more inputs, okay, with the similar one. Thereafter I have to define that one with the in the form of the vector form. In the last class we have seen these things. If I want to define the any input combinations, I have to send the in the form of what, the vector form. If I have the only one output, the only one input or output, that is to be given in the form of what, the single one. It is not in the vector form. That's nothing but scalar form. If I have the more than one input combinations, more than one output combination, then I have to send with the define with the help of what, the in the form of vector form. In the form of vector form. That one will be studying the array of instances. Array of instances. Array of instances, take the idea as the array of instances. In sometimes the okay, for example, here the wire is there. Wire 3:0. Wire 3:0 is there. I can send the wire in 3:0 for the input combinations. So okay, for the input combinations for the in 1 and in 2 also. It means here the in 1 combination and in 2 have the combinations of input combination up to the 4 values, either 0, 1, 2, 3. 4 combinations I can send the for the in 1 and in 2 also. In 1 and in 2. And also similarly for the NAND gate purpose. Okay, for NAND gate we have the only one output, that one is in the form of what, only one input, and also I can send the 4 input combinations from the 0, 1, 2, 3. That's nothing but the 0:3:0, 3:0. It's what, the 0, 0, 0, 1, 1, 0, 1, 1 combination for the input combination for the in 1 and in 2. The only one output I have here, the for the NAND gate here. Similarly, I can also write the, instead of giving the such inputs like this, I can also write the NAND gates with the different while considering the simple one as the NAND N1 as the input combinations as the NAND N2 combinations as the output is only one, that is also having the okay. This is what the how to, okay, we were sending the input combinations while in the form of the vector form, all the forms here. Okay, the output, okay, just to put the inputs as the 0, 0, 0, 0, 0, 0 for the NAND gate, and output is what, the 0 only. For first second combinations 1, 1, 1, 2, 2, 2, 3, 3, 3. Just to copy these things. Just to copy that one. In the some simulations, barkore. In some situations, barkore. In some situations, repetitive instances are required. In some situations, comma, repetitive instances are required. In some situations, comma, repetitive instances are required. Next, these instances differ from each other, full stop. These instances differ from each other only by the index, only by the index of the vector to which they are connected. These instances are differ from each other only by the index of vector to which they are connected. Next point, Verilog HDL allows an array of primitives, Okay, take the assignment. Write a Verilog code for 4:1 mux. 4:1 mux. Write a Verilog code for 4:1 mux, and also simulation, simulation with the test bench program, You should have to come with the solution for this one. Write a program related to 4:1 marks tomorrow. This is what the assignment. Tomorrow's first hour I will take them. There you have to. I have this assignment also. Even I will be explaining this 4:1 marks. Okay, next coming classes will have the writing a program in the form of whatever we have basics we have discussed till today. This one as the today's class also. This is the completely basics. They will not ask for any questions on this one. Definitely tomorrow onwards the questions will be coming. Okay, definitely the questions will be coming for writing a program related to what the sequential logic circuits, even the complex logic circuits also. Okay, this somewhat very easy topics coming classes. Only writing the programs related to half adder, full adder, counter, and also using what the mux says like this. We'll study how to write in the structural model or only what the gate level model. Similar topics are also there in the fourth model, that is to be written in the form of for writing a program, a Verilog program in the form of with the gate level model, and also in the fifth model. In the fifth model we will discuss only the writing a same. Okay, the program for the full adder, half adder, like this we will have the discuss with the writing a program in the behavioral model. Okay, only the writing a program with the help of basics. Very easy concepts are there coming classes, don't worry. I'll be taking the complete solution. I'll give the complete solution to the only one model, that is the third model. Remaining two models you have to give the seminar. Today I'll be sending the topics for the particular students. You have to prepare that one. Okay, don't worry about the stick files. Any of you are given in the third semester, no? Third semester stick file kottiriya? Huh? Those sticks files are with me. Okay, you can collect the sticks files daily. Whoever give the seminar. Okay, but I will not give the stick files directly. You have to come prepare with the seminar topics, at least the 4 to 5 pages. Shantesh. Okay, only the study, only the Simply studying of the topics is not important. You have to give the seminar. By this one, we will get the confidence over the everything. If you are not able to come and stand here, you will not get the job in your life. Okay, you might be getting a very silly ಅನ್ನಿಸುತ್ತೆ. ಏನು ಬರೇ ಕ್ಯೂ ಸ್ಪೈಡರ್ ಬರ್ತದ, ಬರೇ ಜೆ ಸ್ಪೈಡರ್ ಬರ್ತದ. ಗೊತ್ತಾಗ್ತದೆ ಬೆಂಗಳೂರಿಗೆ 80,000 ರೂಪಾಯಿ ಕೊಡ್ರಿ, ಓನ್ಲಿ ಬೆಂಗಳೂರಿಗೆ 80,000 ರೂಪಾಯಿ ಕೊಡ್ರಿ, ಬ್ಯಾನಿಗೆ ಗೊತ್ತಾಗ್ತದೆ. ದುಡ್ದು ರೊಕ್ಕ ಕೊಡ್ರಿ, ಮನೆ ನಾವು ಅಪ್ಪನ ರೊಕ್ಕ ಕೊಟ್ರಲ್ಲ, ನೀವು ದುಡ್ದು ರೊಕ್ಕ ಕೊಡ್ರಿ, ಗೊತ್ತಾಗ್ತದೆ ಅವತ್ತಿನ. ಓಕೆ, ಟುಡೇಸ್ ಡೇಟ್ ವಾಟ್? 10 Where is your 36? 41 46 11 31 This is your first class, no? $96, sir. 74 14 14 9 85 88 Okay, thank you. Okay, you have to give the seminar. ನಾನು ಏನು ಅದರಾಗ ಎಕ್ಸ್ಕ್ಯೂಸ್ ಇಲ್ಲ, ಡೈರೆಕ್ಟಾಗಿ 20 ಮಾರ್ಕ್ಸ್ ಕಮ್ಮಿ ಹಾಕ್ಬಿಡ್ತೀನಿ ನೋಡು.